Hello everyone, we are going to discuss about circuit breaker. We know that every circuit needs a switching device and a protective device. The switching and protective devices have been developed in various forms. So, what is a switchgear? A switchgear is a general term covering a wide range of equipment concerned with switching and also the protection. So, one of the examples of the switchgear is circuit breaker. The name itself says that a circuit breaker is a device which isolates the faulty part of the system in case of any abnormality. So, the function of a circuit breaker is to isolate the faulty part of the power system in case of abnormal conditions. So, now a protective relay detects the abnormal conditions and sends a tripping signal to the circuit breaker. So after receiving the trip command from the relay, the circuit breaker isolates the faulty part of the power system. So a circuit breaker has two contacts. So one is the fixed contact and the other one is the moving contact. The fixed contact and the moving contact, they remain in closed position under the normal conditions. When the circuit breaker gets the trip signal from the relay, then the moving contact moves to interrupt the circuit. So on the separation of the contacts, the flow of the current is interrupted and resulting in the formation of arc between the contacts. So you can observe the formation of the arc here. The contacts are placed in closed chamber containing some insulating medium. So now you are seeing the voltage across the circuit breaker contact. So this figure shows the wave shape of the arc voltage. So this is the wave shape of the arc voltage. The voltage drop across the arc is called as the arc voltage. As the arc path is purely resistive, the arc voltage and the arc currents are in same phase. The magnitude of the arc voltage is very low and it is a few percent of the rated voltage, and a typical value may be about 3% of the rated voltage. Arc interruption methods. There are two methods of arc interruption. One is the high resistance interruption and the current zero interruption. In high resistance interruption method, the resistance of the arc is increased so as to reduce the current to a value insufficient to maintain the arc. The arc resistance can be increased by cooling, lengthening, constraining, and splitting the arc. When the current is interrupted, the energy associated with its magnetic field appears in the form of electrostatic energy. A high voltage appears across the contacts of the circuit breaker, and if this voltage is very high and more than the withstanding capacity of the gap between the contacts, the arc will strike again. Therefore, this method is not suitable for large current interruption, and this can be employed for low power AC and DC circuits. And the other method for the arc interruption is current zero interruption, and this method is applicable only in case of AC circuit breakers. In case of AC supply, the current wave passes through a 0.100 times per second at the supply frequency of 50 Hz. So this feature of AC is utilized for arc interruption. The current is not interrupted at any point other than the zero current instant. Otherwise, a high transient voltage will occur across the contact gap and the arc will strike again. The current is not allowed to rise again after a zero current occurs. So there are two theories to explain the zero current interruption of the arc. One is the recovery wave theory or Sledian's theory, and the energy balance theory or Clausius theory.